In this video, I'm going to simplify some expressions with exponents, and I've tried to choose some examples that are relatively complicated here. So I'll do 4 examples. Okay, so I'm going to simplify these 2 expressions here, and then after these 2 I'll do 2 more. Now this is one of the videos where it's especially important that you sort of pause the video, try the question, see if you can do it, see where you run into trouble, because if you just watch me do it, it's easy. But you'll learn a lot more if you kind of do it along with me. Okay, so the first question is 1/2 m squared n to the exponent -3, and all of that to the exponent -2. Okay, so we'll look inside the brackets first, and there's nothing we can simplify inside the bracket. So we'll use the power of a product rule and apply this exponent, the outside exponent, to every factor in the product inside. So we have 1/2 to the exponent -2 times m squared to the exponent -2 times n to the -3 to the exponent -2. So 1/2 to the exponent -2. A negative exponent means we take the reciprocal of the base. So this will be equal to 2 squared. And then m squared. So here we have a power of a power. We'll multiply the exponents. So we have m to, the exponent will be -2 times -2, which is -4. And then same thing for this part here. We'll multiply the exponents because we have it's a power of a power. So it'll be n to the exponent 6. And this gives us our 2 squared is 4. M to the -4, n to the 6. And we're almost done here, except that when a question asks us to simplify, we should make it so that the answer doesn't have any negative exponents. So to make that exponent on the m positive, I'm going to write it as 1 over the reciprocal. And what this looks, I'll make the base the reciprocal of m. And what this looks like is it looks like this part moves into the denominator. Okay, so this m to the -4 is 1 over m to the exponent +4. And here the 1 is up top, but we don't need to write the 1 because we're just multiplying something by 1, and then we're dividing by m to the exponent 4. Okay, so when we have a negative exponent, it's in the numerator, it essentially turns positive as it goes to the denominator. And if the negative exponent was in the denominator, it'd be the same thing. We can essentially just make it positive as we put it in the numerator. Okay, on to part B. I've got 3 times x to the exponent 1/2 divided by y to the exponent 3, and everything is to the exponent -2. So again, we'll look inside the brackets first and check if we can simplify anything there, but we can't. So we'll apply this exponent to all of the parts. So we have 3 to the -2 times x to the 1/2 to the -2 divided by y cubed to the -2. So 3 to the -2 is 1 over 3 squared. But for right now, so let's write it like this. We'll write it as 1 over 3 squared, which is 9. And then here we have x. The 1/2, all that to the exponent -2. So I'll multiply my exponents because it's a power of a power. So we'll have x. And 1/2 times -2 is -1. And then here I also, in the denominator, I also have a power of power. So I'll have y, and then I multiply my exponents to the exponent -6. Okay, now essentially all of my powers here have negative exponents. My x has a negative exponent, my y has a negative exponent, And here, this is my 3 with a negative exponent, right? Or this is 9 to the exponent negative 1. So what it's going to look like in this last step is sort of that everything changes place from numerator to denominator, or backwards, and all the exponents will become positive. So my 1 over 9, I'll just write as 9 in the denominator, that's the same thing. And the x to the negative 1 will just be 1 over x, which looks like an x in the denominator. And the 1 over y to the negative 6 will just be y in the numerator now to the exponent 6. Okay, now I'm going to look at 2 more examples. Okay, so for my third question here, I've got a times b squared, all that to the exponent 3, times a squared times b, all of that divided by a to the exponent 7, b to the exponent 4, and then the whole shebang is to the exponent negative 1. So basically here there are a number of places I could start, but I'm just going to try to simplify sort of from the inside out. And just because it'll be the easiest if I just quietly simplify a little bit at a time and then work my way out. So the first thing I'm going to do is I've got a power of a product here. So I'll simplify that. So this is, I can apply my exponent to both factors. So I'll have a cubed and b squared cubed. So I'll have a power of a power, and I'll multiply those exponents. So I get b to the exponent 6. Then I'll just copy everything else down here. Okay. Now I'm going to simplify my numerator because I've got some a terms and some b terms twice. If you like, you can rewrite these in another order to group the a's together and group the b's together. So you could write a to the exponent 3, a squared times b to the exponent 6 times b. But I'm going to sort of do that in my head. And I know that when I'm multiplying a cubed times a squared, I've got powers with the same base, so I can add the exponents. So I have a to the exponent 5, and then for the same reason, I can group my b's multiplying powers with the same exponents, so with the same base, so I can add the exponent. And remember that if there is no exponent, it's an exponent of 1. So I've got b to the exponent 7. Then I'll just copy the rest down. A7, b to the exponent 4, all over negative 1. Okay. And now I'm going to use the quotient of powers rule to simplify this fraction inside. So I have a to the exponent 5 divided by a to the exponent 7. So I can subtract my exponents. So that's going to give me a, and 5 minus 7 is negative 2. And I can do the same thing with the b's. I can subtract the exponents. So my exponent is 7 minus 4 is 3. Okay, and now I'm going to finally apply this exponent of negative 1. So I've got a power of a product. So I have a to the negative 2 to the negative 1. Maybe I'll write this step down. So I've applied that exponent to both factors of the product. And now I have a power of a power, so I can multiply the exponents. So negative 2 times negative 1 is 2. And 3 times negative 1 is negative 3. So I'm almost done there, except that when we're asked to simplify, we want to leave all exponents positive. So I have a squared, and then instead of writing b to the negative 3, I'll write 1 over b to the positive 3. Okay, on to the last question. So I've got 2 times a to the exponent 4 times b to the exponent negative 1 times c to the exponent negative 3, all of that to the exponent negative 2. And then we're dividing that whole thing by 4ab squared c to the exponent 4 and then the whole denominator is squared. So if I look in my brackets, there's nothing really I can simplify. Now the one thing I could do, but I won't do, is I could write my negative exponents as positive exponents, but I would suggest you don't do that until the very last step, because it can complicate things more than you need to. So what I'm going to do instead is I'll start applying my power outside the brackets here. So I've got a power of a product, so I can apply this exponent, the negative 2, to every factor in there. So I have 2 to the negative 2 times a to the 4 to the negative 2 times b to the negative 1 to the negative 2 times c to the negative 3 to the negative 2. And then I'll do the same thing on my denominator. I'm going to square each one of these terms. So 4 squared times a squared times b squared squared times c to the negative 4 squared. Okay, so 2 to the negative 2 is 1/4. It's 1 over 2 squared, which is 1/4. A to the 4 to the negative 2. We have a power of a power, so we'll multiply the exponents. So it's a to the negative 8. B to the negative 1 to the negative 2, same thing, we multiply the exponent. It's b squared. And then same thing here, we'll have c to the exponent negative 6. Oh, sorry. This should have been a negative 2 up here, which makes this a positive 6. Because I have negative 2 times negative 3, positive 6. And down here on the denominator we have 4 squared is 16, a squared, b squared squared, so we'll multiply the exponents, b to the exponent 4, and then here on the c I'll multiply the exponents as well, and I get negative 8. Okay, so if we just look at the numbers, we've got 1/4 divided by 16. Which is also the same as 1/4 times 1/16. We get 1 over 64. And then for each of the terms here, for the a's, we have a quotient of powers. So we're going to subtract the exponents. So negative 8, take away 2, is negative 10. And then for the b's, the exponent is 2, take away 4, so it'll be negative 2. And then for the c's, the exponent is 6. Subtract negative 8. We're subtracting a negative, so that's the same as adding, so it's like 6 plus 8 is 14. Okay, we're just about done. I'm just going to take all my negative exponents and rewrite them as the reciprocal with a positive exponent. So, let's see. Essentially, the only thing that's going to stay in my numerator is the c term, c to the 14, because that had a positive exponent. 1 over 64, I'll just write that with the 64 in the denominator. A to the negative 10, I'll write as something divided by a to the 10, and then I'll do the same thing with b. Write that b squared in the denominator. Okay, so the big thing with all these, they're just long and you just have to be really careful all the way down. I would suggest you write out more rather than less. If you try to do too much in your head, you'll make mistakes and sort of get things confused. But if you just work slowly and carefully, there's never any really difficult steps. You just have to be really, really careful and start from the inside and work your way out. Okay, good luck.